Yes, a design temperature exists for dimmers. This temperature is typically 70 degrees Celsius, which translates to 158 degrees Fahrenheit. This specific temperature denotes the maximum operational threshold a dimmer can withstand without incurring damage. Operating a dimmer beyond this designated temperature poses a risk of overheating, potentially leading to premature failure. Understanding this design parameter is crucial for ensuring the longevity and reliable performance of dimmers in various applications. This design temperature is important because it affects the lifespan and performance of the dimmer. When a dimmer operates above its design temperature, the internal components can degrade more quickly. This can lead to a shorter lifespan for the dimmer. Additionally, operating a dimmer above its design temperature can reduce its performance. The dimmer may not be able to control the light level as accurately, or it may produce more heat and noise. Several factors influence the design temperature of dimmers. Firstly, the type of components used in the dimmer's construction plays a significant role. Secondly, the dimmer's physical design and heat dissipation capabilities are crucial. Thirdly, the intended application and ambient temperature conditions contribute to the determination of the design temperature. Different types of dimmers, such as incandescent, LED, and fluorescent dimmers, may have varying design temperatures due to their distinct operational characteristics and component requirements. Furthermore, dimmers intended for heavy-duty applications or use in high-temperature environments will typically have higher design temperatures compared to those designed for standard residential use. It's important to consider the dimmer's design temperature when selecting a dimmer for a particular application. If the dimmer will be operated in a hot environment, you should select a dimmer with a higher design temperature. This will help to ensure that the dimmer operates safely and reliably. To further elaborate, let's consider the individual factors that influence the design temperature in more detail. Firstly, the choice of components significantly affects the dimmer's thermal performance. Resistors, capacitors, transistors, and integrated circuits all generate heat during operation. Components with higher power ratings and better thermal conductivity can withstand higher temperatures. Manufacturers often select components that meet specific temperature requirements to ensure the dimmer's overall reliability. Secondly, the physical design of the dimmer plays a crucial role in heat dissipation. Heat sinks, ventilation slots, and the overall enclosure design can significantly affect how effectively heat is removed from the dimmer's internal components. A well-designed dimmer will have adequate surface area for heat dissipation, preventing the buildup of excessive temperatures. Thirdly, the intended application and ambient temperature conditions influence the design temperature. Dimmers used in enclosed fixtures or in environments with high ambient temperatures will require higher design temperatures to compensate for the reduced heat dissipation. In contrast, dimmers used in open, well-ventilated spaces may have lower design temperatures. The type of dimmer technology also plays a role in determining the design temperature. Incandescent dimmers, which rely on resistive dimming, tend to generate more heat compared to LED dimmers, which use electronic circuits to control light output. As a result, incandescent dimmers often have higher design temperatures. LED dimmers, on the other hand, may have lower design temperatures, but they are still susceptible to overheating if not properly designed. Fluorescent dimmers, which control the current flowing through a fluorescent lamp, also generate heat, but their design temperatures may vary depending on the specific technology used. To ensure that dimmers operate within their design temperature limits, manufacturers often incorporate thermal protection features. These features may include thermal fuses, which interrupt the circuit if the temperature exceeds a certain threshold, or thermal sensors that reduce the dimmer's output to prevent overheating. These protection mechanisms help to prevent damage to the dimmer and ensure safe operation. When installing and using dimmers, it's important to follow the manufacturer's instructions and guidelines. This includes ensuring that the dimmer is properly ventilated and not exposed to excessive heat. It's also important to select a dimmer that is appropriate for the type of lighting load being controlled. Using an incompatible dimmer can lead to overheating and premature failure. To maintain the dimmer's performance and longevity, it's recommended to periodically inspect the dimmer for signs of overheating, such as discoloration or melting. If any signs of overheating are detected, the dimmer should be replaced immediately. It's also important to keep the dimmer clean and free from dust and debris, which can impede heat dissipation. In summary, the design temperature of a dimmer is a critical parameter that affects its lifespan, performance, and safety. By understanding the factors that influence the design temperature and following the manufacturer's recommendations, users can ensure that dimmers operate reliably and safely in various applications. Remember to consult the dimmer specifications for the exact design temperature and operating conditions. This information is typically provided by the manufacturer and can be found on the dimmer's packaging or in the product documentation. Paying attention to these details will help to prevent overheating and ensure the dimmer's longevity. Moreover, understanding the relationship between design temperature and dimmer performance is essential for professionals in the electrical and lighting industries. Electricians, lighting designers, and building maintenance personnel should be aware of the design temperature limits of different types of dimmers and how to select the appropriate dimmer for a given application. This knowledge is crucial for ensuring the safety and reliability of electrical systems. In addition to the design temperature, other factors can affect the dimmer's performance and lifespan. These factors include the load being controlled, the voltage supply, and the ambient temperature. It's important to consider all of these factors when selecting and installing dimmers. The load being controlled refers to the type and wattage of the light bulb or fixture that the dimmer is connected to. Dimmers are designed to work with specific types of loads such as incandescent, LED, or fluorescent. Using an incompatible dimmer can lead to overheating and premature failure. The voltage supply refers to the voltage of the electrical circuit that the dimmer is connected to. Dimmers are designed to operate at specific voltage levels, such as 120 volts or 277 volts. Using a dimmer with an incorrect voltage supply can damage the dimmer and create a safety hazard. The ambient temperature refers to the temperature of the surrounding environment. Dimmers are designed to operate within a specific temperature range. Operating a dimmer outside of this temperature range can reduce its performance and lifespan. To ensure optimal performance and longevity, it's important to select a dimmer that is compatible with the load being controlled, the voltage supply, and the ambient temperature. It's also important to follow the manufacturer's instructions for installation and use. In conclusion, the design temperature of a dimmer is a critical parameter that must be considered to ensure safe and reliable operation. Factors such as component selection, physical design, application, and dimmer technology all contribute to the determination of the design temperature. By understanding these factors and following the manufacturer's recommendations, users can avoid overheating and extend the lifespan of their dimmers. Remember to consult the dimmer specifications for the exact design temperature and operating conditions, and always prioritize safety when working with electrical equipment. Now, let's delve deeper into the practical implications of the design temperature and its impact on dimmer selection and application. When choosing a dimmer for a specific lighting project, it's crucial to consider the environment in which the dimmer will be installed. Will it be located in a well-ventilated area, or will it be enclosed in a tight space with limited airflow? Will it be exposed to direct sunlight or other sources of heat? These factors can significantly affect the dimmer's operating temperature and should be taken into account when selecting a dimmer with an appropriate design temperature. For example, if a dimmer is to be installed in an enclosed fixture with limited ventilation, it's essential to choose a dimmer with a higher design temperature to compensate for the reduced heat dissipation. Similarly, if a dimmer is to be used in a hot climate, it's important to select a dimmer that is rated for high temperature operation. In addition to the environment, the type of lighting load being controlled also plays a role in dimmer selection. Different types of light bulbs and fixtures generate different amounts of heat. Incandescent bulbs, for example, produce a significant amount of heat, while LED bulbs generate relatively little heat. When controlling incandescent bulbs, it's important to choose a dimmer that is designed to handle the higher heat load. In contrast, when controlling LED bulbs, a dimmer with a low design temperature may be sufficient. Furthermore, it's essential to ensure that the dimmer is compatible with the specific type of lighting load being controlled. Using an incompatible dimmer can lead to flickering, buzzing, or even damage to the dimmer or the light bulb. Always consult the manufacturer's specifications to verify compatibility before installing a dimmer. Proper installation is also crucial for ensuring that a dimmer operates within its design temperature limits. The dimmer should be installed in a location where it can receive adequate ventilation. Avoid installing dimmers in enclosed spaces or near sources of heat. Also, make sure that the dimmer is properly wired and that all connections are secure. Loose or faulty connections can generate heat and lead to overheating. Regular maintenance can also help to extend the lifespan of a dimmer and prevent overheating. Periodically inspect the dimmer for signs of damage or wear. Check for loose connections, cracks, or discoloration. Clean the dimmer regularly to remove dust and debris, which can impede heat dissipation. If you notice any signs of overheating, such as a burning smell or excessive heat, turn off the power to the dimmer immediately and consult a qualified electrician. In addition to selecting the right dimmer and installing it properly, it's also important to use it responsibly. Avoid overloading the dimmer by connecting too many light bulbs or fixtures. Overloading can cause the dimmer to overheat and fail prematurely. Also, avoid using the dimmer to control appliances or other electrical devices that are not specifically designed for dimming. Using a dimmer for unintended purposes can damage the dimmer and create a safety hazard. In summary, the design temperature is a critical parameter that affects the performance, lifespan, and safety of dimmers. By understanding the factors that influence the design temperature, selecting the right dimmer for the application, installing it properly, and using it responsibly, users can ensure that dimmers operate reliably and safely. Remember to consult the manufacturer's specifications for the exact design temperature and operating conditions, and always prioritize safety when working with electrical equipment. Also, remember that some dimmers have a minimum load requirement. This means that they need to have a certain amount of wattage connected to them in order to function properly. If the load is too low, the dimmer may not work at all, or it may flicker or buzz. Check the manufacturer's specifications to determine the minimum load requirement for the dimmer. Another important consideration is the type of dimming technology used in the dimmer. There are several different types of dimming technologies available, each with its own advantages and disadvantages. Some common dimming technologies include leading edge dimming, trailing edge dimming, and pulse width modulation (PWM) dimming. Leading edge dimming, also known as forward phase dimming, is a traditional dimming technology that is commonly used with incandescent bulbs. Trailing edge dimming, also known as reverse phase dimming, is a more advanced dimming technology that is often used with LED bulbs. PWM dimming is a digital dimming technology that is used in some LED dimmers. The choice of dimming technology can affect the performance of the dimmer and the compatibility with different types of light bulbs. It's important to select a dimmer with a dimming technology that is compatible with the type of light bulb being controlled. Furthermore, some dimmers have features such as soft start and fade-in/fade out. These features can help to extend the lifespan of the light bulbs and provide a more pleasing dimming experience. Soft start gradually increases the voltage to the light bulb when it is first turned on, which reduces the stress on the filament and extends its lifespan. Fade-in/fade out gradually dims the light bulb up or down, which provides a smoother and more visually appealing transition. Consider these features when selecting a dimmer for a specific application. In addition to the technical aspects of dimmers, it's also important to consider the aesthetic aspects. Dimmers are available in a variety of styles and finishes to match the decor of any room. Choose a dimmer that complements the overall aesthetic of the space. Also, consider the location of the dimmer switch. It should be easily accessible and conveniently located for the user. Finally, remember to always follow the local electrical codes and regulations when installing and using dimmers. Electrical work can be dangerous, and it's important to take precautions to prevent accidents. If you are not comfortable working with electricity, hire a qualified electrician to install the dimmer. In conclusion, selecting and using dimmers requires careful consideration of various factors, including the design temperature, load compatibility, dimming technology, features, aesthetics, and local electrical codes. By taking these factors into account, users can ensure that dimmers operate safely, reliably, and efficiently.